Hello my dear students, this is P. Venkateshwarlu, PGT Physics. Okay, today we will discuss about elastic collisions in two dimensions. Elastic collisions in two dimensions. Elastic collision in two dimensions or oblique collision. Oblique collision. Okay. See here, elastic collision means we know that. Okay. So in which type of collision momentum and kinetic energy conserves, that type of collision we can say yes, elastic collision. Okay, see here oblique collision. Oblique collision means okay, so after collision the two bodies are moving with different directions. Okay, so which makes some angle. That angle is less than 90 degrees. That type of collision we can say oblique collision. Means from the horizon the angle made by the particle or object which is the angle is less than 90 degrees. This type of collision we can say oblique collision. So already here 2D collision, two dimensions. If the collision occurs in a plane, means not in a straight line, this type of collision we can say collision in two dimensions or oblique collision. Okay, in this type of collision consider two objects, okay, two bodies. So we know that their mass is m1, m2. Okay, initially these two are in straight line. First body having velocity u1, second body velocity according to the condition u2 is equal to 0. That is the condition. Okay, after collision, these two bodies are moving with different velocities and different directions. Okay, understand here two bodies. Here m1 mass, here m2 mass. Okay, here the angle made by the m1 body with the horizon is theta. The angle made by the body 2 means m2, which is angle phi, my dear children. Angle phi. Okay, understand my dear children? It is visible? Yes. Okay, here m2 is rest, m1 having some velocity. Due to the velocity, m1 and m2 collision occurs. In this type of collision, these two bodies are moves in different direction, which make different angle with the reference line. Okay, according to the component of vector, we can split the momentum along x and along y. So without splitting of this momentum, it is impossible to get the final velocities and momentum. Understand, my children? According to vector notation, consider a point. Okay. So this is direction, the component of momentum along x-axis and the momentum of first body along y-axis. We can split the momentum horizontal and vertical. Here we know that momentum is m1 v1 cos theta. Here m1 v1 sin theta. Here at this point this is the momentum along x along y. Here angle phi, we know that m2 v2 cos phi. Here m2 v2 sin phi, my children. Okay, understand? See here. So according to this content, so we can calculate the momentum, the conservation of momentum along x and along y. Okay, see here along y direction, momentum. What is the momentum? Okay, according to conservation of linear momentum, okay, the momentum before the collision is equal to the momentum after the collision, my children. Yes. Okay, see here, this is y direction, y axis. y-axis. Here x-axis. X-axis. Okay, here, see here, along y direction there is no initial momentum. Along y-axis there is no initial momentum. Means, see here, m1 0 plus m2 0. Understand? So along y-axis there is no velocities because these two bodies are moving x direction. So that's why y direction there is no velocities. Okay, and here in the component of momentum along y direction, m1 v1 sin theta, m1 v1 sin theta. Okay, understand? Then the momentum along negative y direction, m2 v2 sin phi minus m2 v2 sin phi. Okay, angle phi it is denoted the angle made by the second body with horizon or reference line. Okay, understand? So rearrange this. So we can say 0 is equal to m1 v1 sin theta minus m2 v2 sin phi. This is equation 1. This is equation 1 minus. Okay, understand? So same along x direction, conservation of linear momentum. Along x direction, conservation of linear momentum. Okay, understand my children? Along x direction, according to conservation of linear momentum. According to conservation of linear momentum, the momentum before the collision is equal to the momentum after the collision. See, m1 u1 plus m2 0 because which is at rest. Okay, along horizontal, the final momentum of the first body after collision, m1 v1 cos theta plus m2 v2 cos phi. Okay, understand my children? So m1 u1 is equal to m1 v1 cos theta plus m2 v2 cos phi. So this is equation 2. This is equation 2. Okay, understand? So then according to conservation of kinetic energy, along y direction. Okay, so we know that along y direction there is no initial velocities. Okay, the component of vector along y direction and it is possible. Okay, so 1 by 2 m1 0 square plus 1 by 2 m2 0 square is equal to 1 by 2 m1 v1 sin theta whole square plus 1 by 2 m2 v2 sin phi whole square. Okay, rearrange this. 0 is equal to 1 by 2 common, we can say on left side it becomes 0, m1 v1 square sin square theta plus m2 v2 square sin square phi. This is equation 3. My children. Okay, understand? This is equation 3. Okay, so be careful. Without this diagram you are unable to understand. Be careful. Diagram is very, very important. Yes, next, according to conservation of kinetic energy in elastic collision. Okay, so here we know that x-axis 1 by 2 m1 u1 square plus 1 by 2 m2 0 square, which is equal to 1 by 2 m1 v1 sin theta whole square plus 1 by 2 m2 v2 sin, sorry, here cos theta v2 cos phi whole square. So rearrange this 1 by 2 gets cancelled. m1 v1 square is equal to m1 v1 square cos square theta plus m2 v2 square cos square phi. This is equation 4. Understand, my dear children? Understand? Here we can have some cases. Case 1. So glancing collision means in glancing collision, here the second body means phi is equal to 90 degrees. My dear children. And theta is equal to 0. Next, case 2, head-on collision. Means, in this case, head-on collision means theta is equal to 0. Then phi is equal to 0. Theta is equal to 0 and phi is equal to 0, my dear children. Okay, so we know that, my dear children, elastic collision in 2 dimensions means we know that elastic collision, after collision the kinetic energy and momentum conserves. This type of collision we can say elastic collision. Okay, in 2 dimensions means the collision occur in a plane, okay, not in straight line. Oblique collisions means after collision. So the meaning is after collision these 2 bodies are moving with a different direction. Okay, so the 2 bodies are making angle with the reference line is less than 90 degrees. This type of collision we can say oblique collision. Okay, see here equation 1, 2, 3, 4 is there. Equation 1, 2, 3 is and 4. So by using this parameters, so say m1 u1 here m1. Okay, we can measure the angles. My dear children. Okay, so if they given angle, we have to find the final velocities. Okay, so like that, vice versa. If they given some values, we have to find other values. Okay, this is the content, my dear children. Restitution. Okay, coefficient of restitution or coefficient of resilience. Okay, it is denoted E. So we know that, my children, 2 bodies m1 u1 m2 u2, they are collide each other and these bodies are moving with different velocities. Okay, understand, this is collision. So in this case, Okay, coefficient of restitution, it is defined as the relative velocity of separation or the relative velocity after the collision to the relative velocity of approaches are before collision. Okay, the ratio, the relative velocity before the collision to the relative velocity after the collision. Okay, see here, perfect elastic collision. Elastic collision E is equal to 1. Okay, perfect elastic collision E is equal to 0. In elastic collision, 0 less than E less than 1. Okay, understand? For elastic collision, E is equal to 1. This ratio is 1. Okay, understand? So it becomes, see here, E is equal to, you can write V2 minus V1 divided by U1 minus U2. This is the formula, my teacher. This is the formula. Okay, so what is coefficient of restitution? Yes, coefficient of restitution, which is defined as the ratio of relative velocity after the collision to the relative velocity before the collision. Understand, my children? Yes. So this is the formula. The value of coefficient of restitution E is equal to 1 for elastic, E is equal to 0 for perfectly elastic. In inelastic collision, 0 less than coefficient of restitution less than 1. Rebouncing of ball, my children. Okay, see here. So consider a ball. You can drop some height h. Okay, so it rebounds. Okay, understand? Rebounds and again bounce. Again bounce down and bounce up. Okay, continuously fallen up. Finally h value 0. Understand? So if a ball dropped from some height, again rebounds. Okay, again falls, again rebounds, again falls and rebounds and continuously like that. Okay, see here h, we know that h we can give. Okay, so after nth collision, okay, so how we can find h? Hn is equal to, formula is there, Hn is equal to, okay, h into e power 2n. Okay, Hn, height of the nth bouncing or nth collision. In this case, say it is 1, 2, 3, 4, 5, 6, 7, 8 like that. Okay, h initial height. Okay, so Hn is equal to my children h into e power 2n. Second one, total distance traveled by this particle s is equal to 1 plus e square by 1 minus e square. Okay, S is equal to h into 1 plus e square divided by 1 minus e square, 1 minus e square. Okay, understand? This is the content, my children. Okay, see here, rebouncing of ball means consider a ball and drop from some height. It will rebouncing back and up, okay, continuously at particular time. H value 0. Okay, in this case, height of the nth bouncing. Okay, so particular bouncing we have to find height means by using this formula, h into e power 2n. Okay, next total distance, like this. This total distance we have to find by using this total distance. S is equal to h into 1 plus e square by 1 minus e square. Okay, we know that e is equal to 1 for elastic, e is equal to 0 for perfectly elastic. E value 0 less than e less than 1 means inelastic, my children. Okay, understand, my children? So if you have any doubts, contact me. Okay, so and already I send Monday worksheet. Okay, all of you remember it. You can send that answers to my WhatsApp number individually. Okay, so for that also you have internal marks. Okay, my children? Yes.